Welcome to our deep dive into AI research. Today we're looking at the O1 Replication Journey, a paper that's kind of like a research diary. It chronicles a team's efforts to recreate the capabilities of OpenAI's O1 model, which is pretty mysterious, even for experts.
Yeah, it's a bit of a black box. But what's really cool about this paper is how open they are about everything. Right in section 1, the introduction, they lay out all the challenges in AI research right now, like um, development times being so long, teams working in silos, information trickling out really slowly. It's like they're saying all this slows down progress.
They're saying, let's throw open the doors and show everyone what's cooking in AI. That's pretty brave, especially with so much AI research being top secret.
Exactly. And they actually do it. They document their whole process, not just the good stuff either, but also the struggles, the dead ends, even the brainstorming sessions. It's all there in section 2, a strategic progress report.
Wow, so they're really putting it all out there. Makes you wonder if this kind of openness could become the new normal for AI research.
It would be interesting to see. And it leads to some really cool discoveries. Like one of the most fascinating things they talk about is this idea of journey learning.
Okay, I'm intrigued.
So in section 3, towards building an O1, they talk about how traditional AI training is all about shortcut learning, just getting the AI to the right answer as fast as possible. But journey learning is different. It encourages the AI to like learn through trial and error, reflect on its mistakes, backtrack when it goes down the wrong path.
Like the difference between cramming for a test and actually engaging with the material.
Exactly. And the results are promising. In section 4, journey learning, they talk about how they used it on a math dataset. Got over 8% improvement over traditional methods. And get this, they only needed 327 training samples.
That's incredible, especially since everyone always says more data is better in AI.
Yeah, it definitely challenges that assumption. Now, one of the most exciting parts of this paper is the peek it gives us into how O1 actually thinks.
Okay, tell me everything.
So in section 5, Understanding O1, they analyze O1's outputs. And what they found is really cool. As the tasks got more complex, O1's thoughts, that's what they call them, became longer and more complex too.
So it's not just blindly following instructions, it's like actually thinking things through.
Right, almost like a human reasoning process, considering options, weighing pros and cons, changing its approach when it needs to.
Wow. So they analyze these thoughts.
Yeah, and they found these keywords like consider, if, possible, wait, even alternatively. It's like O1 is actually deliberating, exploring different paths, and even correcting itself.
So O1 isn't just spitting out answers, it's thinking about the best way to get there.
That's what it looks like. And this long thought process, that's the core of journey learning, and the team wanted to figure out how to recreate it. They actually tried 4 different approaches, which they describe in section 6, replicating long thoughts.
Okay, so what were they?
First, tree search with LLM and reward.
So what does that even mean?
They were thinking of the AI's reasoning process as a tree, with each node being a step in the thought process. And they used a reward model to guide the AI through this tree, rewarding it for taking steps towards the right solution, penalizing it for wrong steps. And if the AI goes down the wrong path, the reward model encourages it to backtrack and try a different route.
So giving the AI a map and a compass to navigate a maze.
Perfect analogy. Then they tried a propose critique loop. The AI would propose a step and then critique its own proposal, evaluating if it would lead to the solution, almost like debating with itself.
It's like the AI is anticipating pitfalls and refining its strategy.
Exactly. The third approach was a multi-agent approach. Multiple AIs working together, like a team of detectives pooling their clues.
Okay, that's fascinating. What was the fourth?
Complete human thought process annotation. They carefully documented how human experts solve problems, not just the steps, but their reasoning, their intuitions, even their frustrations.
Like trying to capture the inner monologue of a chess grandmaster.
Precisely. And they use this detailed documentation to understand how humans solve problems. Now, to evaluate each step, they needed to be able to assess its correctness. So they developed reward models, which they talk about in section 6.4, reward model.
To tell the AI how close it was to the right solution at each step.
Exactly. They tested different models on benchmark datasets, like subsets of PRM 800K and MRGS M8K. These are datasets specifically for math reasoning. And they found that a model called O1 Mini was the best. In Table 4, performance of reward models on subset of PRM 800K, and Table 5, performance of reward models on MRGS M8K, they show that O1 Mini had much higher F1 scores than the other models, meaning it was much better at judging how correct each step was.
So O1 Mini is like a really good judge for the AI's thought process.
That's a good way to put it.
So how did they actually build these on-policy reasoning trees?
They explain that in Section 6.5, construct on-policy reasoning trees. They started with a pre-trained language model called DeepSeek Math 7B Base, which they've fine-tuned on the ABLE dataset, creating a model they called ABLE DS Math. This became their policy model for generating reasoning steps.
So AbleDS Math is like the engine driving the AI's thought process, proposing steps in the solution.
Right. But to keep it on track, they needed a reward model for feedback. They tried two, Math Shepherd and O1 Mini.
And we know O1 Mini is the star player when it comes to evaluating those steps.
Absolutely. Math Shepherd gives a probability score for each step, but they found that O1 Mini, which just says if a step is right or wrong, was better, especially for tougher problems.
So it's like a stricter teacher who doesn't give partial credit.
Exactly. And this rigorous approach helped them prune away incorrect branches in their reasoning trees, making it more efficient.
It's like carefully shaping a bonsai tree.
Precisely. Building the trees was just step one. The real challenge was extracting the long thoughts, as they call them, which is in Section 6.6, extract long thoughts.
And they weren't just trying to find the shortcut to the solution, right? They wanted to see the whole thought process.
You got it. They wanted the whole journey, including the wrong turns and the lessons learned.
How'd they do that?
They started by finding the shortcut, the direct path to the answer. But then they used a depth-first search, or DFS, algorithm to explore the whole tree. This algorithm goes as far as it can down each branch before backtracking, so they documented not just the right steps, but the wrong ones too, and why the AI took them.
It's like exploring every corner of a maze.
Exactly. But a reasoning tree can be huge, especially for hard problems, so they set some limits, constraining how many trials the AI could do at each node.
So they were setting boundaries for the AI's exploration.
Yes. And by putting together the steps and reasoning from this limited exploration, they created a rough draft of their long thought. But it was a little rough, not very smooth or coherent.
Like a brilliant but disorganized thinker trying to explain themselves.
Exactly. So they brought in GPT-4o, another large language model, to help.
Like a skilled editor polishing a rough draft.
Exactly. The result was a long thought that really captured the human-like journey of solving a problem, complete with insights, mistakes, and even some narrative flair.
It's like turning a jumble of puzzle pieces into a beautiful mosaic.
That's a great way to picture it.
So how did they evaluate all this?
In Section 6.7, Visual Data Analysis, they describe this cool visual data analysis platform they built using Streamlit, which is a framework for making interactive web apps.
So they built a custom tool to help them understand the data.
Right. This platform let them see the reasoning trees, the long thoughts, and the model outputs in a really clear way. They could filter the data, see if the model got the answer right, or if its output had keywords showing reflection or hesitation.
Like a microscope for thought.
Exactly. They could even compare different versions of their data and models side by side to see what effect their changes had.
Real-time feedback loop for the AI's development.
You got it. This visual analysis platform was key for them to understand the AI's thinking and improve their approach.
So they had their data and their evaluation methods. What next?
The training phase, which is in Section 6.8, training, they used a two-phase process, supervised fine-tuning, or SFT, and then direct preference learning, or DPO.
Okay, break that down for me.
In the SFT phase, they fine-tuned their language model using both shortcut learning and journey learning. With shortcut learning, they only used responses with the correct steps and final answer. But with journey learning, they exposed the model to the full, long thought with all the trials and errors.
So it's like comparing a student who memorizes the textbook to one who actually grapples with the material.
Yes, and in the DPO phase, they generated multiple responses for each question in the math-trained dataset. These were labeled as positive or negative based on whether they got the right answer. Then the model was trained to tell the difference, learning to prefer the solutions that actually worked.
So they're teaching the AI to recognize successful thought patterns.
That's a great way to put it. And the results, well, they were amazing. In Table 6, Performance on Math Test Set, you can see that journey learning did much better than shortcut learning.
Tell me more about those results. How much better?
Journey learning was over 8% better than shortcut learning on the math test set. It suggests that showing the model the full complexity of human thought, even the mistakes, actually makes it smarter.
That's a huge leap forward.
It is. And we're back, diving deeper into the O1 replication journey.
It's been fascinating to see how this team is trying to reverse engineer how O1 thinks.
Yeah, and along the way, they're finding some really cool things about how AI could learn more like we do.
Let's pick up where we left off. What's next for this research project?
Well, they've got a whole roadmap laid out in Section 8, Future Work, and it's full of exciting possibilities.
Like what?
First off, they want to scale up how they're integrating long thoughts.
So pushing the AI to think harder, consider more options, really flex its cognitive muscles.
Exactly. They're thinking about problems that need multiple lines of reasoning, different problem-solving strategies, all that.
It's like giving the AI a bigger playground, more tools, and seeing what it can build.
I like that analogy. They're also interested in the scaling laws of long thought.
Okay, now what does that mean?
They want to figure out how the performance of journey learning changes as you change the amount of data, the size of the model, the computing power, all of that.
So finding the best recipe for intelligence.
Right. They think understanding these scaling laws is going to be huge for developing really advanced AI in the future.
It's like unlocking the secrets of how to make the AI even smarter.
And they also want to develop better ways of evaluating the AI, as they mentioned in Section 8.3, better evaluation.
Because just looking at whether it gets the answer right isn't enough, is it?
Nope. They want to go deeper. Look at the quality of its thinking, how well it explains itself, how close it is to human reasoning.
It's like judging a painting. You care about the technique, the creativity, not just the final product.
Exactly. This team is really serious about pushing the limits of how we evaluate AI.
And they think humans and AI need to team up to do it right.
Right. In Section 8.4, Human-AI Collaboration, they talk about building tools and systems that let humans and AI work together smoothly.
Like a conductor and an orchestra, each bringing something special to the performance.
Love that. Of course, they're going to keep improving their reward and critique models, too. They mentioned that in Section 8.5, better reward and critique models.
Making sure the AI is getting the best possible feedback to learn and grow.
Yep. And they want to explore even more advanced ways to use reasoning trees, maybe even using multiple AIs that work together, which they talk about in Section 8.6, further integrating reasoning tree.
A whole society of AI mimes.
I know, right? And they're also going to keep developing their training methods, which they talk about in Section 8.7, more sophisticated training methodology.
Always experimenting, always trying to find new ways to train AI.
And importantly, they're staying committed to being open and sharing their work. Like they say in Section 8.8, resource sharing.
Sharing their knowledge and tools with the whole AI community.
Because they believe open science is the key to making faster progress in AI.
It's about everyone working together, learning from each other's successes and mistakes. Now, before we move on, I want to go back to something we talked about earlier, those on-policy reasoning trees.
They go into detail on that in Section 6.5, construct on-policy reasoning trees.
Right, they started with that DeepSeek Math 7B-based language model and fine-tuned it on the ABLE dataset.
And that's how they got ABLE DS Math, their policy model for making reasoning steps.
And then they used O1 Mini to make sure those steps were leading in the right direction.
Yep. O1 Mini was really good at figuring out if each step was correct.
I remember that. Now, what I found really cool was how they got those long thoughts out of the trees.
They explain that whole process in Section 6.6, extract long thoughts.
They didn't want the AI to just find the quickest solution. They wanted to see its whole thought process.
Absolutely. All the steps, the mistakes, everything.
And they used a depth-first search algorithm to go through the entire tree.
Right. They wanted to see all the paths, not just the shortest one.
But they had to set some limits, right?
Yeah.
To keep the search manageable.
Yeah. They limited how many trials the AI could do at each step.
So they were setting boundaries for the AI.
Yep. And by putting together all the steps and the reasoning behind them, they made a first draft of the long thought.
Which was a little messy at first, right?
It was. So they used GPT-4o to smooth it out and make it more readable.
Like an editor polishing up a manuscript.
Exactly. The end result was a long thought that really showed how the AI was thinking, its insights, its mistakes, everything.
It really gave you a sense of how the AI was learning and understanding.
Right. And then there was that visual data analysis platform, which they talk about in Section 6.7, visual data analysis.
That was so cool.
They built it using Streamlit, which lets you create interactive web apps.
So they could really dig into their data and see what was going on.
Exactly. They could see their reasoning trees, the long thoughts, and what the model was outputting.
It was like they had X-ray vision for the AI's thought process.
That's a great way to put it. They could filter the data, compare different versions of their models, and really get a detailed understanding of the AI's thinking.
And that platform was crucial for their research, right?
Definitely, it helped them make better decisions about how to improve their models.
It really shows their commitment to understanding how AI works.
Absolutely. Now, before we wrap up this part, there's one more thing I wanted to touch on. Their discussion of data annotation in section 6.9. Data annotation, human AI collaboration.
Ah, yes, the human side of things.
They really emphasize how important it is to capture the whole human thought process when you're teaching AI.
Not just telling it what to think, but showing it how to think.
Right. And they even talk about the need to explain common sense knowledge to the AI.
So it doesn't make assumptions that don't make sense to us humans.
Exactly. It's all about bridging the gap between human intuition and how AI reasons.
It's really insightful how they approach data annotation.
It highlights how important humans are in shaping how AI develops.
It shows that collaboration between humans and AI is key to creating truly intelligent machines.
Absolutely.
Welcome back for the final part of our deep dive into the O1 replication journey.
It's been amazing to explore how this team is trying to rebuild O1 from the ground up.
And they're finding out some really interesting stuff about AI along the way.
Yeah, they're definitely pushing the boundaries.
So for this last part, I want to talk about what's next for this project.
They've got a whole section on that, section 8, future work. And it's pretty ambitious stuff.
What are they thinking about?
Well, they don't just want to copy O1, they want to take journey learning even further.
So make AI even better at learning through trial and error, reflection, all that.
Exactly. One thing they're really interested in is scaling up those long thoughts even more.
Making the AI's thought process even more complex, more like a human's.
Yeah, they want to look at problems that need the AI to think in a lot of different ways, use different strategies.
It's like giving it even more challenging puzzles to solve.
I like that. And they also want to investigate those scaling laws of long thought we talked about before.
Right, figuring out how journey learning works when you change the amount of data, the model size, all that.
Exactly. They think figuring that out will be key to building the next generation of AI.
It's like unlocking the secrets of AI intelligence.
And they also want to come up with even better ways to evaluate how well the AI is doing, which they discuss in section 8.3, better evaluation.
Because, like we said, it's not just about getting the right answer. It's about how you get there.
Exactly. They want to look at the quality of the AI's reasoning, how well it can explain itself, how much it resembles human thinking.
It's like, judging a piece of art. You look at the technique, the creativity, not just the finished painting.
Right. And they believe that to do this really well, humans and AI need to work together.
They talk about that in section 8.4, human-AI collaboration, don't they?
They do. They want to build tools and systems that make it easy for humans and AI to collaborate.
Each one bringing their own strengths to the table.
Exactly. And of course, they're going to keep refining those reward and critique models too, like they mentioned in section 8.5, better reward and critique models.
To give the AI the best possible feedback as it learns.
Yeah, help it grow and reach its full potential. And they also want to look into even more advanced ways to use those reasoning trees, maybe even having multiple AIs work together to solve a problem, like they say in section 8.6, further integrating reasoning tree.
It's like creating a whole team of AI brains.
Right. And of course, they're going to keep working on their training methods, always looking for better ways to train AI, which they mention in section 8.7, more sophisticated training methodology.
So it's a process of constant improvement and experimentation.
Exactly. And throughout all of this, they're committed to being open and sharing what they learn, like they say in section 8.8, resource sharing.
Making sure the whole AI community can benefit from their work.
Because they believe that open science is the best way to move AI forward.
It's about everyone working together towards a common goal.
Exactly.
Well, this has been an incredible deep dive into the O1 replication journey. It's really made me think about the future of AI.
Me too. It's such a fascinating and rapidly evolving field.
I think this research shows us just how much potential AI has to not only solve problems, but to do it in a way that's more and more like how humans think.
Absolutely. And the commitment of this team to openness and collaboration is really inspiring. It gives me a lot of hope for the future of AI research.
Thanks for joining us on this journey. We hope you found it as fascinating as we did.